This is the Brennan Monorail, designed by Australian inventor and engineer Sir William George Brennan in the early 20th century, was an innovative concept that sought to revolutionize transportation. It was an elevated rail system that used a unique gyroscopic balancing mechanism, making it a significant departure from conventional railway designs. The monorail was proposed as a way to address issues such as congestion and inefficiency in existing transportation systems. The Brennan Monorail was envisioned to have a single track upon which a vehicle would be suspended, and its motion would be stabilized by large, rotating gyroscopes. These gyroscopes were designed to create stability and prevent the vehicle from tipping over, even when negotiating sharp turns or encountering sudden movements. The operation of a gyroscope, which is central to the Brennan Monorail, can be understood through the principle of angular momentum. Gyroscopes are spinning wheels or discs that maintain their orientation due to the conservation of angular momentum. When the gyroscope spins at high speed, its axis of rotation resists changes, allowing it to stabilize the vehicle it is attached to. This resistance to changes in orientation helps to keep the vehicle upright, even under challenging conditions. In the case of the Brennan Monorail, these gyroscopes would counteract any forces that could cause the vehicle to tip or wobble, making it safer and more reliable for high-speed travel on elevated tracks. Balancing the Brennan Monorail involved the strategic placement and rotation of these gyroscopes within the vehicle, which worked in conjunction with the vehicle's speed and the forces acting on it. The spinning gyroscopes would provide a force that stabilized the vehicle against tipping, essentially creating a dynamic system that could keep the monorail balanced while navigating various obstacles. The idea was revolutionary at the time, as it offered a solution to the problem of balance that typically plagues vehicles on elevated or curved tracks. If implemented successfully, the Brennan Monorail could have paved the way for a new form of urban and intercity transit, free from many of the issues that hindered conventional railroads and trams. However, despite its promising design, the Brennan Monorail never became a commercial success. The technology was ahead of its time, and the concept faced numerous challenges, including the complexity of building the system, the cost of the gyroscopes, and the practicality of manufacturing and maintaining such a unique system. Additionally, transportation networks at the time were heavily invested in traditional rail systems, and the cost of transitioning to something as radically different as the Brennan Monorail was a significant hurdle. The project faced resistance from both the public and private sectors, and though it generated some interest, it was never fully realized on a large scale. Brennan's monorail prototype was constructed in limited trials, but it ultimately failed to attract enough investment or support to become a widespread transportation solution. Despite its failure, the Brennan Monorail was a fascinating example of visionary engineering that anticipated many of the transportation challenges faced by modern cities. The principles behind the gyroscopic balancing system continue to influence transportation and engineering designs, and the concept of monorails, although not exactly like Brennan's original design, has persisted in modern urban transit systems around the world. Today, the legacy of the Brennan Monorail serves as a reminder of how bold ideas can sometimes be too ahead of their time, but also how they can inspire future innovations in technology and transportation.